Welcome to Carlton's Math Corner. Today we are going to discuss decimals to fractions. At this time, please make sure that you have your vocabulary packet, your notebook, as well as something to write with. Our target today is I can write a repeating decimal as a fraction in simplest form. So as you can see right here, here's some repeating numbers. Notice they repeat a bunch of different patterns. This one repeats just one number. This one repeats three. Some of them even repeat just two numbers. But we have this line across it to tell us that it is a repeating decimal. This line is referred to as the repetant sign. And so what we're going to do today is we're going to take these decimals and we are going to write them as a fraction. And I know that seems pretty complicated because it's, usually with a fraction, if we want to write a decimal as a fraction, usually we just place, a 1 under that decimal point and then we figure out how many place values there are. Well, this isn't, all of these have infinite number of place values. So how do you know what goes underneath these decimals? How do we know what goes underneath these place values? And so what I want you to notice, well, first of all, 0.3 repeating is one of those common decimals. And some of you may remember from in the past that 0.3 repeating is 1/3. Same thing is true with 0.6 repeating. That is also another common one, and that is 2/3. But I want you to see this less common one, 0.16 repeating, and I want you to notice the steps that are taking place. Just make some observations. What do you notice is happening? Okay, so let's take a look. Okay, so step number 1, here's what I notice. I notice that literally I'm taking 0.16 and I'm writing it out a few times. I can't write out all the digits because this is an infinite pattern, but I put it equal to x. Okay, step 2, I notice that there's 100 in front of the x, and I wonder to myself, why would there be 100? And is it always going to be 100? And I noticed that the decimal point moved over twice, because look over here, now it's 16.161616. Step 3, I noticed that I am subtracting this one in orange from this one in red. So I'm taking 100x equals 16.16 repeating minus x equals 0.16 repeating. And then step 4, I notice that it looks like I'm solving for x, because if I take 100 minus, even though there's no number here, there's still a 1, so really it's 100 minus 1, so that's 99. And then 16.16 repeating, subtracting 0.16 repeating, I get just 16. And so if I solve for x, I just have to get x alone, so I need to divide by 99. And so, whoa, there's my fraction, 16/99. Okay, so let's write out these steps. So the first thing, step number 1, I write my decimal equal to x. Okay, step number 2, I write a multiple of 10 next to the x. Now look at this one. Let's go back. This one is 100. That's a multiple of 10. Why do you think it's 100? Why don't you think it's 10 or 1,000 or 10,000? Yeah, do you notice that your pattern, look at your pattern. There's only 2 numbers that repeat. So that means I only need 2 numbers, to put a repetant sign over. Well, look at how many zeros the 100 has. 2. So if I have 2 numbers that repeat, I need 2 zeros. If I have 1 number that repeats, I only need 1 zero. If I have 3 numbers that repeat, Now I have 3 zeros. Okay, so the multiple of 10 depends on how many numbers are in your pattern. So the multiple of 10 is determined by the number of repeating numbers. So you need to count how many numbers are repeating, and that is what multiple 10 you use. Step number 3, we subtract. We subtract the multiple of 10 and the x, and then we subtract the 2 decimals. So if you look at this, we subtracted the multiple of 10 minus the x, and remember there's always one x, and then we subtracted the 2 decimals that we have after we move that decimal point over. Notice when you subtract them, we get a whole number. We get a whole number because all these repeating numbers, they're exactly the same. So when you subtract them, I mean, they zero out each other. So all we have is the whole number that's in front after we move over that decimal point. Remember, if there's 2 zeros from our multiple of 10, we move the decimal point over twice. Okay, and I guess I forgot to say that part in step number 2. It says, write the multiple of 10 next to x and move the decimal over the number of zeros. Okay, and so when we subtract, they subtract each other out, and we get a whole number. Step number 4, it says, solve for x. Well, when we subtract them, we get it down to, well, in this case, 99x, so there'll always be something in front of the x, equals our whole number on the other side. So all I have to do, really, is divide by whatever number that is next to x, because there will always be a number next to x. And the opposite of a number next to a variable, well, it's times right now, and the inverse of it would be division. So we're dividing by 99. I can't do 66 divided by 99. Well, I could, but that'd get me back to my decimal. But I'm going to leave it as a fraction because that's what I need. So then I simplify if needed. Sometimes you need to, but I'm going to say most of the time, you're not going to need to simplify. Okay? So here's what I would like you to do. I want you to try these 3 problems. Remember, the number of numbers that repeat, that is the multiple of 10 that you use. Okay, so try that out, write them as fractions, and you know, test it out and see. So I'm going to put write the following decimals as fractions. And let's change this to black because, ooh, that red is really bright. Okay, so write the following decimals as fractions in simplest form. Okay, so make sure you are in simplest form. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again. Have a great day. See ya.